In the first reaction, copper is going to react with nitric acid to produce copper nitrate, nitrogen dioxide, and water. Now first, to balance the equation, you have to figure out how many of each element are on each side. There's one copper on this side and one on this side. And then there's one hydrogen and 2 on this side because it's H2. For nitrogen, there's 1 on this side and 2 there because that's in brackets with the 2. 3. So 3. And then there's 3 oxygen and 1, 2, 3. And then there's 2 of those. 6, 7, 8, 9. Now let's start trying to even out nitrogen. So since there's 3 nitrogens on this side, we want to have 3 nitrogens on this side. So then that would change it to have 3 hydrogens, 3 nitrogens, and 9 oxygens. So right now nitrogen and oxygen are equal, and so is copper, but hydrogen is not. So what we want to do next is even out the hydrogens. So since there are more on the left than there are on the right, you want to add more to the right. So let's start by putting a 2 there. See what happens. There are now 4 hydrogens there, and 1 more oxygen. That's 10. So now we have to go back to the left and get another oxygen. So let's change that to a 4. See what happens. There are now 12 oxygens, 4 nitrogens, and 4 hydrogens. Now let's even out the oxygen again. We need 2 more. Since there are 2 oxygens there and the nitrogen is also not equal, 4 and 3, if we double that, so there's now another nitrogen and 2 more oxygens. So now it is balanced.
The bubbles indicate that a chemical reaction is occurring.
In the second equation, we start with copper nitrate and sodium hydroxide, and they form copper hydroxide and sodium nitrate. So the elements copper on this side, there's 1. On the other side, there's 1. For nitrogen, there's 1, 2 on this side, and 1 on the other. Oxygen, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5. Hydrogen, 1 and 2. And sodium, there is 1 and 1. So first we can balance the nitrogens. So since there are 2 on this side and 1 on this side, we can put a 2 in front of there. And then that changes that to 2. And then it adds another sodium also. And 3 more oxygens. So next we can balance the sodium. Put a 2 in front of there, which changes that to 2 sodiums, 8 oxygens, and 2 hydrogens. And then here's the balanced equation. In the next equation, we will be taking the copper hydroxide and heating it to change it to copper oxide and hydrogen. So, on the left side, there's 1 copper, and then 2 oxygens because of the 2 outside the parentheses, and 2 hydrogens. And then on the right side, there's 1 copper there, 1 oxygen, and 2 hydrogens. So to balance the oxygens on this side, because there's 1 on this side and 2 on the other, we're going to need to put a 2 in front of this. And so that changes it to 2 oxygens, except then there's 2 coppers. So then on this side, if we put a 2 in front of there are now 2 coppers, 2, I think I balanced that wrong. I don't think that's right. So previously I said that copper hydroxide would separate into copper oxide and hydrogen once it was heated. But that is not correct, since there are now 4 oxygens there. Since the two sides can never be equal, the real outcome should be water instead of hydrogen. So then now, there's 1 copper, 2 oxygens, and 2 hydrogens on this side. And on the other side, there's 1 copper, 2 oxygens, and 2 hydrogens on this side. So now it is balanced. Copper oxide and hydrogen was released. The fourth conversion we will do will be converting copper oxide into copper chloride by adding hydrogen chloride or hydrochloric acid, and then the result would be copper chloride and water. So the elements are copper, oxygen, hydrogen, and chloride. There's 1 copper on this side and 1 on the other. 1 oxygen and 1 hydrogen, and there's 2 on that side, and then 1 chloride and 2 chlorides. Now the hydrogen and the chloride are not equal, so we can start with hydrogen. We need to have 2 on that side, which changes there to be 2 hydrogens and also 2 chlorides. So now the equation is balanced. In the previous reaction, we combined copper oxide and hydrochloric acid to form copper chloride and water. Since we added more hydrochloric acid than was able to be all used up with the copper oxide, there's still some hydrochloric acid left over that will also be used in the next reaction. When I add aluminum to the test tube, the copper chloride will react with the aluminum, but also the aluminum will react with the leftover hydrochloric acid. So, for the copper chloride and aluminum, it forms copper and aluminum chloride. And then, on this side, there's 1 copper, 2 chlorides, and 1 aluminum. And on the other side, there's 1 copper, 3 chlorides, and 2 aluminums. So let's start with aluminum. Since there's 2 on that side, we need to have 2 on this side. So that changes that to 2. So now the chlorine is not equal. So since there's 2 and 3 and there's no easy way to just double it, you have to put 3 in front of this, which is the opposite of there, and a 2 in front of there. So now they should be balanced. There's 6 chlorides now, and 6 chlorides. And then 3 coppers, and 4 aluminums. But since that is still not equal, we need to balance the copper now. If we put 3 there, there's now 3. But we need 1 more, or 2 more aluminums. Change that to 4. But that's not balanced yet, because 4, 4, 6, 6. Oh, that is balanced. Okay. So along with the copper chloride reacting with the aluminum is going to now react with the hydrochloric acid to form hydrogen and aluminum chloride. So on this side there's 1 aluminum, 1 hydrogen, and 1 chlorine. And on the other side there's 2 hydrogens, 2 aluminums, and 3 chlorines. So the first easiest thing to balance would be the hydrogen. There's 2 on this side and 1 on this side. So there needs to be 2. And that changes, so there are now 2 hydrogens, but there are also 2 chlorines. Next, the aluminum can be balanced. There's 2 on this side and 1 on this side. So we do the same thing. We put a 2 in front of it, and now there are 2. But the chlorine is still not equal. So we need to, since there's no easy way to balance them by multiplying it by 2, because that doesn't get 3, you would need to multiply them by each other. So we need to put the 3 on this side. 2 times 3 is 6. Now there are 6 hydrogens and 6 chlorines, and then the 2 of those gives you 4 aluminum and 6 chlorine. Now the chlorines are equal, but the aluminum and the hydrogen are not. To get 6 hydrogens on this side, we can put a 3 in front of it, because 3 times 2 is 6. Then the aluminum, we already have 2, so we just need to double that to get 4. And now the equation is balanced.